Today we're going to do 7-2 and 7-3 multi-step equations. 7-3 are just multi-step equations with decimals, so we're just going to kind of throw them all together. Okay, so 7-1 was two-step equations, but now we have more than two steps. Okay, so the key here is to combine like terms on the same side of the equal sign, or distribute first. So you might have to distribute, you might be combining like terms, but you do everything that's on the same side of the equal sign, then you isolate the variable by solving. Okay, so that's the key. We'll just start doing some examples. The first one here, m plus 2m minus 4, oh, that's a little close there, but that's just minus 4 equals 14. So we have m and 2m, those are like terms. Remember, there's really a 1 right here. So this is 3m minus 4 equals 14. Now it's a two-step equation like we did in 7-1, I'm sorry. So we're going to add 4 to both sides. What we do to one side, we have to do to the other. And we get 3m equals 18. And then we're going to divide by 3. M equals 6. And you're done. Okay. Going over here to number 2, we look at our like terms. Now, like terms don't necessarily have to have variables. They could be integers. Okay. It's not on this one, but it could be. So 4a minus, because remember you go with what's in front. So this is really 4a minus a. So this takes us back all the way back to chapter 1, combining those like terms. So that's really 3a plus 1, because we still have this 1, equals 19. So now it's just a two-step equation. Okay, we're going to subtract 1. What you do to one side, you have to do to the other. 3a equals 18. Divide by 3. A also equals 6. They're not all going to equal 6. Okay. Moving on to the next one. So now we have 4d plus 2d minus 3d. So 4, 5, 6, and then 5, 4, 3. Excuse me. 3d equals 27. Excuse me. Sorry. So 3d equals 27. So now this is just one step. Divide by 3. Divide by 3. D equals 9. And you're done there. Okay? Now on this one, we're not combining, but we're distributing. Remember the distributive property. Okay, that 3 goes to everything inside. So it's 3 times n minus 3 times 2. You do not have to do this step. I'm just showing you what we're doing to remind you. So this is going to be 3n minus 6 equals 36. And now we isolate the variable and solve. So we add 6. What we do to one side, we have to do to the other. So we have 3n equals, what is that, 42. Okay, and then we divide by 3. Woo, let's go up here. N equals 3 goes into 4 once, 14. Is that right? Yeah. 14. Excuse me, I'm sorry, it's gross. Okay. Doing some more. So 21 equals 2 times 4a plus 2. So when you see these parentheses, if you can't combine what's inside the parentheses, then you need to distribute if there's something to distribute out here. So 21 equals, so 2 times 4a, which is 8a, 2 times positive 2, which is 4. Okay, and then we're going to subtract 4. So 21, what is that? 17, 21, 20, 19, 18, 17 equals 8a. Okay, divide by 8. You're not always going to get nice, neat numbers, and I'm wondering if yeah, so we just left it as a fraction. A equals 17 over 8, so change that to improper. 8 goes into that 2 times 2 and 1/8 is what you should end up with. Change it to a mixed number, okay? Change it to a mixed number. If you don't start with a decimal, you can end with a decimal. The ones that have decimals, you can end with a decimal, but otherwise leave it as a fraction. Okay, so here we're going to distribute. Don't forget to take that -3. So -3 times 2y is -6y minus 21, or plus a -21 equals -18. So again, we're going to try to isolate that variable. We add 21. Okay, so 6y equals, so we have a -18 plus 21. So that's going to give you +3 because we have -$18 and then we pay them back $21. So we're actually in the positives. Okay, divide, you want to isolate the variable, divide by -6. So y equals, don't forget to reduce, -1/2. Remember that negative can go anywhere as long as there's just one of them. Okay. Okay, over here. So I'm going to rewrite this. Again, my program won't let me. 2/3 n minus 6 equals 22. Okay, so the first thing we're going to do is we're going to add 6. This is really just a two-step equation, but it has that fraction in there. 2/3 n equals 28. Okay, so remember when it's 2/3 times n, okay, you can divide by 2/3, which is the same as multiplying by the reciprocal. So we just do that from the beginning because we want this to equal 1. Okay, so what we do to one side, we do to the other. So 3 over 2, this is really 28 over 1. These will cancel. N equals, okay? So remember when you multiply, you can just multiply across. 1 and 2 goes into that 14 times. So now it's 14 times 3, which is what we had earlier, isn't it? 42, okay? 3 and 4 is 12, 3, 4, yeah, 42, okay? Whoops. All right. So coming over here, now we have more than one fraction. Okay, so we have, if you want to rewrite it, that's fine. 2/5 x plus 2 equals 3/4. So again, we're going to subtract our 2. Subtract 2. So we have 2/5 x. You can put this in your calculator. You can do 3/4 minus 2. Okay, you should know that you're going to get -1 and 1/4. Okay, 1 and 1/4 plus 3/4 would give you -2. Because you're actually subtracting because one's negative and one's positive. Okay, now let me, yeah, I'm just making sure. If you need to find a common denominator, that's fine. Otherwise, just put it in your calculator. At this point in the year, you can put this in your calculator. I do not mind. Okay? So now, I'm going to rewrite it up here. We have 2/5 x equals, I'm going to go ahead and make this into an improper fraction. I'm sorry. So this is going to be -5/4. I'm so sorry. I have something in my throat. So it's 2/5 times x. So again, we're going to multiply by the reciprocal, which is 5/2. Okay. So x equals, and it's going to be negative because a negative times a positive is a negative. So we have 25 on the top, 8 on the bottom, and we want our answer to be a mixed number though. So 8 goes into 25 3 times, -3 and 1/8. And let me see if I did that right. Yep, that's the right answer. Okay, 2 more. So this is a decimal. We didn't do a lot of decimals just because I know you know how to deal with decimals. So 1.5x minus 3.x equals 2.4. Okay, so again, you don't change anything. You're trying to isolate this variable, so you're going to add 3.6. What you do to one side, you do the other. So you add 3.6. 1.5x equals, and since they're both positive, you just add it up. 3, 4, 5, so it's going to be 6 or 6.0, however you want to look at it. Make sure that I have the right. Okay, and so since it's 1.5 times x, you're going to divide by 1.5. And you can do all of this in your calculator. I'm totally fine with that. X equals 4. Okay? Now, number 10 seems to throw people for a little bit of a loop. Okay? The sum of 3 consecutive integers is 96. Find the integers. There's different ways to do it. I'm going to show you how to make an equation and do it. I don't mind if you do it other ways, but I do want you to be able to do it this way. The sum of 3 consecutive integers is 96. So first of all, consecutive means what? It means one right after the other. Okay? Integers means they are whole numbers and they're opposites. So it could be -5, -4, 0, 1, 2, 3, 4, any of those. Okay? So let's say we have to have a variable. So n is going to be your first integer. Well, since they're consecutive just means if the first number is 5, the second number is 6. It's right after, and since they're integers, we can't use decimals. So it would be n plus 1 would be your second integer. N plus 2 is your third integer. If you start it like this, it makes things so much easier. So now it says the sum, which is just adding together, the sum of 3 consecutive integers is 96. So we can just take these 3 things, add them together, and have it equal 96. So n plus this next one, which is n plus 1, plus this next line, which is n plus 2, equals 96. I'm so sorry. So we're going to combine like terms. So we have 3n plus 3 equals 96. And then we just solve. Subtract 3. So 3n equals 93. Divide by 3. N equals 31. So that's what n is, but it says find the integers. So if 31 is n, whoops, oh darn it. If 31 is n, see if I can fix that. If 31 is n, then the next number would be 32 and the next one would be 33. Okay, now sometimes I might give you one that says the sum of 2 consecutive even integers. So if it was an even integer, it'd be n, and then n plus 2, n plus 4, or n plus 6, depending on how many it's asking for. Okay. Let me exit out. I think that's it. There might be a... Oh, here's a little...